The numbers came in last Tuesday. Scientists monitoring the equatorial Pacific Ocean stared at their screens and then looked at each other, because what the data was showing them wasn't what they had hoped for. Sea surface temperatures in the central and eastern Pacific had risen again. The pressure gradient had shifted again. The trade winds had weakened again. This El Niño weather pattern, already active, already disrupting rainfall across multiple continents, had just gotten stronger, and the implications of that single update ripple outward in ways that most people never hear about. Into agriculture, into water supplies, into wildfire risk, into disease patterns, into global food prices, into the quiet daily lives of billions of people who have never heard the term El Niño, and have no idea that a warming strip of ocean halfway around the world is already reshaping their reality. Today, we're going to change that. We're going to tell you exactly what's happening in the Pacific right now, why it's getting stronger, what that means for the months ahead, and why, in a world already destabilized by climate change, a strengthening El Niño is not just a weather update. It is a global warning. To understand why this latest update matters, you need to understand the timeline. El Niño events don't arrive overnight. They build slowly in the deep layers of the Pacific Ocean over months. Scientists track their development through a combination of ocean buoys, satellite imagery, weather balloons, and the most sophisticated climate models ever built. The monitoring system watches a specific region of the tropical Pacific, a stretch of ocean from roughly the international dateline to the coast of South America. It's called the Niño 3.4 region. When sea surface temperatures in this region rise more than half a degree Celsius above the long-term average and stay there, an El Niño is officially declared. This current event was declared after months of building ocean heat. At first, it was moderate, significant but within historical norms. Forecasters predicted it would peak, plateau, and begin to fade. Then the latest data arrived. Instead of plateauing, temperatures in the Niño 3.4 region continued climbing. The atmosphere above began responding more strongly, weakening the trade winds further, which allowed more warm water to spread eastward, which raised temperatures further. The feedback loop that drives El Niño intensification was running hot. What had been a moderate event was reclassified, and the forecast models, which had been cautiously optimistic, shifted towards scenarios that were considerably less so. The El Niño had gotten stronger, and the world needed to know. The process by which an El Niño intensifies is one of the most elegant and most dangerous feedback systems in the Earth's climate. It begins with the trade winds. In normal years, powerful easterly trade winds blow across the tropical Pacific from South America toward Asia. These winds push warm surface water westward, piling it up near Australia and Indonesia. The western Pacific sits beneath a thick layer of warm water. The eastern Pacific stays relatively cool, but when something disrupts those trade winds, a random atmospheric fluctuation, a pocket of unusually warm water, the balance begins to tip, the winds weaken. Warm water that was being pushed west starts to slosh back east, and the eastern Pacific warms. And here is where the feedback begins. Warmer water in the east means more evaporation. More evaporation means more rainfall over the central Pacific and less over the western Pacific. That shift in rainfall patterns changes the atmospheric pressure distribution. Those pressure changes weaken the trade winds further, which allows more warm water to move east, which warms the ocean more, which weakens the winds more. The system feeds on itself. And in the current event, that self-feeding cycle has been running longer and more powerfully than many forecasters anticipated. The ocean heat content in the tropical Pacific, the total amount of heat stored in the upper layers of the ocean, was exceptionally high going into this event, due in part to the long-term warming of the oceans driven by climate change. More heat in the system means more fuel. More fuel means a stronger El Niño, and a stronger El Niño means more disruption across more of the world for longer. When El Niño strengthens, it doesn't just affect the Pacific, it reaches into the atmospheric circulation patterns of the entire planet, shifting jet streams, repositioning storm tracks, and rewriting the seasonal weather forecast for regions that may be thousands of miles from the Pacific Ocean. Let's go region by region. In North America, a stronger El Niño typically means a wetter than normal winter across the southern United States, from California through Texas and into the southeast. The EO storm track shifts southward, and atmospheric rivers, long corridors of intense moisture flow, can repeatedly hammer the California coast. At the same time, the northern United States and Canada tend to experience warmer, drier winters. The Great Plains may see reduced snowpack, affecting spring river flows and summer agricultural water availability. In South America, the effects are sharply divided. Ecuador and Peru on the Pacific coast often see extreme rainfall and flooding, the very phenomenon that gave El Niño its name, as Peruvian fishermen first noticed the unusually warm coastal waters appearing around Christmas. Meanwhile, southern Brazil, Argentina, and Uruguay can see wetter conditions. But the Amazon basin, the lungs of the planet, often faces drought during strong El Niño events, stressing one of the world's most critical ecosystems. In Australia, El Niño is associated with drought. The continent's rainfall patterns depend critically on the temperature contrast between the Indian and Pacific Oceans. When the Pacific warms, that contrast shifts, and Australia, particularly its eastern agricultural heartland, can see dramatically reduced rainfall, crop failures, reservoir depletion, elevated wildfire risk. In Southeast Asia and India, El Niño tends to suppress monsoon rainfall. The monsoon is not just a seasonal weather pattern for these regions. It is the foundation of agriculture, water supply, and daily life for billions of people. A weakened monsoon during a strong El Niño event can mean drought, crop failure, water stress, and the cascading social and economic pressures that follow. In East Africa, the short rains that fall between October and December are often enhanced by El Niño, which can sound like good news, but intense concentrated rainfall on drought. Hardened soils often runs off rather than soaking in, causing flash floods while leaving aquifers unreplaced. And in the Caribbean and the Gulf of Mexico, El Niño suppresses Atlantic hurricane activity by increasing wind shear, the difference in wind speed and direction at different altitude, that prevents hurricanes from organizing. This is one of the few traditionally positive effects of El Niño for North America, though it is worth noting that a stronger El Niño does not eliminate Atlantic hurricanes. It simply reduces their frequency, while doing nothing to reduce the intensity of those that do form. This is the global reach of a strengthening El Niño. It doesn't affect one place, it affects everywhere, differently, simultaneously, and at a scale that no single government or international body is fully equipped to manage. Of all the consequences of a strengthening El Niño, the one most likely to affect the greatest number of people, most of whom will never connect their rising grocery bills to a patch of warm ocean in the Pacific, is the impact on global food production. Agriculture is fundamentally a weather-dependent enterprise. Crops need rain, but the right amount of rain, at the right time in the right season. They need temperatures within certain ranges. They need growing seasons that arrive on schedule. El Niño disrupts all of these with brutal efficiency, and it does so across multiple major agricultural regions simultaneously. Consider what a stronger than expected El Niño means for the current growing season. In Australia, one of the world's largest exporters of wheat, a developing drought could reduce harvest yield significantly. In Brazil, the world's largest producer of soybeans and a critical supplier of coffee, sugar, and corn, erratic rainfall patterns could stress crops at key growth stages. In India, where hundreds of millions of smallholder farmers depend on the monsoon, a suppressed rainy season could reduce rice and wheat production, the dietary staples of the world's most populous nation. Meanwhile, in regions where El Niño brings excess rain, the damage is equally real. Flooded fields cannot be planted. Saturated soils promote root disease and fungal infections. Harvested crops stored in humid conditions spoil. Roads made impassable by floods prevent food from reaching markets. The net effect across global markets is predictable. Supply falls, demand remains constant, and prices rise. We have seen this pattern before. The 2010-11 El Niño contributed to food price spikes that were among the triggers of social unrest across the Middle East and North Africa. The 1997-98 event disrupted agricultural production across 4 continents simultaneously. A stronger than forecast current event, playing out on top of already elevated food prices following years of supply chain disruption, could push food insecurity to levels not seen in decades. The people who will feel this most acutely are not commodity traders watching screens in Chicago or London. They are families in low-income countries who spend 60, 70, 80% of their income on food, and for whom a 20% price increase is not an inconvenience. It is a crisis. Food gets most of the attention when we discuss El Niño impacts, but there is another resource, more fundamental even than food, whose disruption by a strengthening El Niño may prove equally consequential. Freshwater systems, rivers, lakes, glaciers, aquifers, and reservoirs are exquisitely sensitive to changes in precipitation patterns, and a stronger El Niño reshapes precipitation at continental scales. In regions facing El Niño-associated drought, reservoirs that supply drinking water and irrigation shrink. Rivers that power hydroelectric dams run low, causing not just water shortages, but electricity shortages in regions that depend on hydropower. Groundwater aquifers are drawn down faster as surface water disappears, and they recover slowly, sometimes over years or decades. Peru offers one of the starkest examples. The country's major cities, including Lima, a metropolitan area of over 11 million people, depend heavily on rivers fed by Andean glaciers. Those glaciers have been shrinking for decades due to global warming. El Niño events alter the precipitation patterns in the Andes, sometimes causing intense rainfall that triggers flooding and landslides while delivering less snow to the high-altitude glaciers that are the long-term water bank. In southern Africa, the Zambezi River Basin, which supplies water to Zimbabwe, Zambia, Mozambique, and several other nations, is dramatically affected by El Niño-driven drought. The Kariba Dam, one of the world's largest hydroelectric reservoirs, has reached critically low levels during past El Niño events, forcing power rationing across multiple countries simultaneously. And in South and Southeast Asia, where river systems originate in Himalayan and Tibetan glaciers fed by monsoon snowfall, a weakened monsoon means less snowpack, which means less meltwater flowing into agricultural systems during the dry season the following year. Water disruption is slower than flood disruption. It unfolds over months rather than hours. It does not generate the dramatic imagery of storm surge or swollen rivers overtopping their banks. But its consequences, strained agriculture, public health crises from inadequate sanitation, economic slowdowns from energy shortfalls, can be more persistent and more deeply damaging than any single flood event. A strengthening El Niño sets off chains of consequence that extend far beyond the immediate weather impacts into domains that seem, on the surface, to have nothing to do with ocean temperatures in the Pacific. In Australia, El Niño conditions, heat, drought, dry vegetation, are the preconditions for catastrophic fire seasons. The Black Summer fires of 2019-2020, which burned more than 18 million hectares and killed or displaced an estimated 3 billion animals, occurred against a backdrop of El Niño-influenced heat and drought. Future strong El Niño events, superimposed on a warming climate, could produce fire seasons that dwarf even that catastrophe. In the Amazon, drought stress from El Niño combines with ongoing deforestation to create tinderbox conditions. The Amazon does not naturally burn. It is a rainforest, its vegetation perpetually moist in normal years. But when El Niño-driven drought dries the canopy, and when deforestation has removed the moisture-generating trees that normally keep the regional climate humid, fire spreads in ways that are both ecologically catastrophic and globally significant, releasing enormous stores of carbon into the atmosphere. In Indonesia and Malaysia, El Niño-associated drought creates conditions for the burning of peatlands, ancient deposits of compressed organic material that, when dry and ignited, can smolder for months, releasing smoke that blankets entire regions and carbon that has been stored for thousands of years. Disease is another cascading effect that receives far less attention than it deserves. El Niño conditions alter the geography of disease vectors. Mosquitoes, rodents, and other organisms whose populations expand or contract with changing rainfall and temperature patterns. Malaria transmission shifts geographically. Dengue fever outbreaks intensify in areas experiencing unusual rainfall. Cholera risk rises in communities where flooding overwhelms sanitation infrastructure. A study published in the journal Science found that El Niño events significantly increase the risk of civil conflict in affected tropical regions, a finding driven in part by the economic and food security pressures El Niño creates, but also by the social disruption that follows disease outbreaks, displacement, and resource competition. The storm, the drought, the fire, the flood, the crop failure, the food price spike, the disease outbreak, the conflict, these are not separate stories. They are chapters of the same story, and a strengthening El Niño is the author. Right now, teams of scientists around the world are watching this El Niño with extraordinary intensity. NOAA's Climate Prediction Center in College Park, Maryland, issues regular updates, analyzing buoy data from the TAO Triton Array, satellite sea surface temperature, measurements, atmospheric pressure readings, and the outputs of multiple climate models. Their forecasts are read by agricultural ministries, disaster management agencies, humanitarian organizations, and financial markets. The European Center for Medium-Range Weather Forecasts, widely regarded as operating the world's most accurate climate models, has been tracking this event's development and issuing its own forecasts. The Japan Meteorological Agency, Australia's Bureau of Meteorology, the UK Met Office, and climate agencies across South America, Asia, and Africa all contribute to the global picture. What are they watching for? First, the peak. Every El Niño eventually reaches its maximum intensity, the point at which sea surface temperature anomalies in the Niño 3.4 region stop rising. Knowing when the peak will occur is critical for forecasting the severity of regional weather impacts. Second, the duration. Some El Niño events peak sharply and fade quickly. Others plateau at high intensity for months. A prolonged peak means prolonged drought in affected regions, with less time for soil moisture and reservoir levels to recover before the following growing season. Third, the transition. After El Niño peaks, the Pacific typically shifts toward neutral conditions, and sometimes swings all the way to La Niña, the cool phase that brings its own set of global weather disruptions. The timing and nature of that transition matters enormously for water resource planning, agriculture, and disaster preparedness. And fourth, the interaction with everything else. This El Niño is not developing in a climate vacuum. It is developing in the warmest ocean in recorded history, in an atmosphere with the highest concentration of greenhouse gases in human history, in a world where the baseline conditions that determine how El Niño affects regional weather have themselves shifted due to decades of warming. The scientists are not just watching an El Niño, they are watching an El Niño in a world that has never existed before. Given everything we know, given the strengthening of this event, its global reach, and the amplification provided by a warming world, what should actually be happening right now? At the international level, early warning information needs to be translated into early action. The science is there. The forecasts exist. What is chronically lacking is the political and financial mechanism to act on those forecasts before disaster strikes, rather than mobilizing only after communities have been devastated. The United Nations Early Warnings for All initiative, launched in response to growing evidence that many countries lack adequate early warning systems, is a step in the right direction. But initiatives require funding, political commitment, and ground-level implementation that often stalls in the gap between international announcements and local action. At the national level, governments in El Niño vulnerable regions should be activating contingency plans now, not when the drought has already bitten, not when the crops have already failed. Now, while there is still time to pre-position food reserves, adjust irrigation schedules, alert farmers to expected conditions, prepare health systems for disease outbreaks, and ensure that the most vulnerable communities have what they need before the worst arrives. At the community level, and this is where it matters most, local knowledge and local networks are irreplaceable. Communities that have experienced past El Niño events often have practical wisdom about what works, which crops are more drought resistant, which water sources remain reliable, which flood-prone areas must be evacuated early. That knowledge needs to be supported, not replaced, by top-down interventions. And at the individual level, wherever you are in the world, awareness matters. Understanding that the drought in your region, or the unusual rainfall, or the price of bread at your local market, is connected to a large-scale planetary system that is currently amplifying. That understanding changes how you think about what's happening and what might come next. The headline said, "This El Niño weather pattern just got stronger." 5 words, a data update, a shift in a number on a scientific chart. But behind those 5 words is a story that spans the entire planet. Farmers in India watching cloudless skies during what should be monsoon season. Reservoir managers in Australia calculating how many months of water remain. Families in the Horn of Africa stretching food supplies against a timeline they cannot see. Wildfire crews in Indonesia watching drought-stressed forests with dread. Scientists in a dozen countries updating their models and their forecasts and their warnings. El Niño is not a villain. It is a natural feature of the climate system, ancient, cyclical, and in its own way, essential. The climate patterns it drives redistribute heat and moisture in ways that have shaped ecosystems and human civilizations for millennia. But we are living in a time when the natural world and the human-altered world are colliding with increasing force. When natural climate variability plays out against a backdrop of human-caused warming, the results are not simply the sum of the two. They interact, they amplify. They produce outcomes that fall outside the range of historical experience. This El Niño is stronger than it was last week. It may be stronger still next month. The global weather machine is already responding. Somewhere, right now, it is raining harder than it should. Somewhere else, it is drier than it has been in years. Somewhere, a forecast is being revised, a warning is being issued, a family is making decisions with information they may not fully have. The science is telling us something important. The question, as always, is whether we are listening.